Let's look at number 3. Number 3 is asking, consider these two entries from a fictional table of standard reduction potentials. Which pair of species would react under standard conditions? And it gives you these 3 here, or 4 options here. So x2 plus 2e minus would get me x solid. This e here would be 2.22 volts. And then y2 plus 2e minus give me ys. E would be 0.21 volts here. So it's asking which pair of species would react under standard conditions here. So when we look at standard reduction potentials, we're looking at, okay, hydrogen, again, I have my standard reduction potentials here. These are all being reduced, right? I'm gaining electrons in this case. X2 plus gains electrons to form X solid. Y2 plus here is going to gain 2 electrons to form Y solid here. If you remember, recall the hydrogen is our base kind of point here at 0, right? So anything that's above, in terms of above here, it's going to be, these are both positive charges, right? So 0.21 is very, very close to this this guy here, right? It looks like very 0.22 here. So this, you can think of this as like sodium. This is silver chloride. Reduction of silver chloride gives you silver plus the silver solid and the chlorine ion, and 2.22 is all the way up here, right? It's all the way up here in terms of the half reaction. This is very, very electronegative here, because again, F2 plus is very electronegative. This is also very electronegative here. So you can assume that X here would be a halogen, whereas 0.21 is again less reactive here. So it's asking us which pair of species would react under standard conditions. So we know that because X2 here has such a great reduction potential, X2 is obviously going to react here, and it's going to probably react with our Y here, right? So again, it says the most positive will reduce here. So again, this is my most positive volts here, so it's going to reduce, which is correct, which is therefore this one here will oxidize. So this case, we're gonna have this species here, so X2 and Y, which is the correct answer here. So let me just show you. So it means because this value here is greater than this value, this reduction will happen, right? So I'm gonna get this reaction here is going to be my reduction, and if I have a reduction, something needs to be oxidized, right? So so this guy here is going to get oxidized here. So it's gonna be YS is going to form these 2 guys here. So this one will oxidize. So which reactions will react together? I can basically cross these guys out to form my net ionic equation, which is X2 plus here, sorry, plus YS would give me XS plus Y2 plus. So these 2 guys here are going to be my reactants, or pairs of species that will react. So X2 plus and Y here is the correct answer. So solution is correct. Good analysis here. You really just care about the reduction potentials, right? If the higher the reduction potential, obviously the reduction will happen. And if the reduction will happen, then the other one will have to be an oxidation reaction. Solution here is correct.